Hi guys, so today we're going to take a look at question 3 of the 2017 exam paper 1. Okay, so we want to differentiate 1/3 x squared minus x plus 3 from first principles with respect to x. Okay, so straight away, whenever you hear differentiate with respect to first principles, what this means is to use the definition of the derivative, which is the limit as h goes to 0 of the difference between f of x plus h minus f of x all over h. So basically the infinitesimally small slope of f at x. Okay, so this is the definition of the derivative. Okay, and so we want to use this definition to differentiate f, or differentiate this 1/3 x squared minus x plus 3. So let's just let f of x, let our function be 1/3 x squared minus x plus 3. And so, well, what is f of x plus h? Well, just put in x plus h wherever you see x, equals 1/3 x plus h squared minus x plus h plus 3. So let's just tidy this up a bit. We get 1/3 x squared plus 2/3 xh plus 1/3 h squared, and then minus x minus h plus 3. Okay, so then let's put this into our expression here, this limit as h gets really small. So the limit as h goes to 0 of f of x of h, which is just 1/3 x squared plus 2/3 xh plus 1/3 h squared minus x minus h plus 3 minus f of x, which is just 1/3 x squared minus x plus 3 all over h. Okay, so there are a lot of things here will cancel straight away. So the 1/3 x squared will cancel. The minus x will cancel. Actually, let's use a different color here. 1/3 x squared, the minus x, and the 3. All of these will cancel. So that leaves us with a limit as h goes to 0 of 2/3 xh plus 1/3 h squared minus h all over h. And now the problem before was that if we let h get smaller and smaller, let's say we let h be all the way to 0, then we'd get 0 on the top and 0 on the bottom, and we don't know what that is. It's indeterminate. But now we can take out a common factor of h from our fraction, from the numerator. We get h times 2/3 x plus 1/3 h minus 1 all over h. And now we can get rid of this h on the bottom because it cancels with the h on the top. And so now we have a limit that we can actually work with. The limit h goes to 0 of 2/3 x 2/3 x plus 1/3 h minus 1. And the limit as this goes to 0, well, 2/3 x and minus 1 aren't affected. They're going to stay as 2/3 x. But 1/3 h is going to get smaller and smaller and smaller until it is 0. And so the limit as h goes to 0 of this is just 2/3 x minus 1. And if you differentiated this normally, you would see very quickly that the derivative is 2/3 x minus 1. And this is just the more classical way of going about it. So let's actually just write this is the derivative of x. Okay, now on to part B. F of x is ln 3x squared plus 2, and g of x is x plus 5, where x is real. Find the value of the derivative of f of g of x at x equals a quarter. Give your answer correct to 3 decimal places. So this question has two pretty obvious steps. One, find the derivative, which is the harder step by quite a bit. And the second step is evaluate the derivative for x equals 1/4. And the second step we're not even going to worry about until we complete the first step. Okay, so finding the derivative. Okay, so first of all, let's just write down our functions. So f of x is the natural log of 3x squared plus 2, and g of x is just x plus 5. Okay, so, and we're looking for the derivative of f of g of x. Okay, so whenever you're looking for the derivative of a function, so f is our function, and then f of another function g, you should immediately think of the chain rule. And so the chain rule says that if you have a function f of x equals u, some function of another function, then the derivative of x is the derivative of u with respect to v times the derivative of v with respect to x. Okay, and so what does that mean? So it essentially means, so in our case, let's say if we call h of x f of g of x, then the derivative of h is the derivative of f evaluated at g of x, so f prime of g of x, actually it's sort of in the way, f prime of g of x times g prime of x. So the derivative of f with respect to g times the derivative of g with respect to x. Okay, and so now we have to find f prime. What is f prime of x? And then we could just sub in g of x. Well, f is ln 3x squared plus 2. So this is actually another chain rule. So the derivative of f is the derivative of the natural log, which is 1 over whatever is in here, 1 over 3x squared plus 2 multiplied by the derivative of whatever is in here. And so the derivative of the argument, or the derivative of, the derivative of what's in, 1 over 3x squared plus 2 times the derivative of 3x squared plus 2, which is 1 over 3x squared plus 2, because it's another chain rule, times 6x. So this is just 6x over 3x squared plus 2. Okay. And now, so that's the derivative of x. And so now we want the derivative of g. So the derivative of g of x is just the derivative of x plus 5, which is easy. It's just 1. Okay, so now we can go back to, now we can actually find the derivative we're looking for. H prime of x, the derivative of f of g of x, is f prime of g of x, so it's all very complicated. F prime of g of x times g prime of x, but this is just 1, so we can actually just ignore it because it won't do anything. And f prime of g of x, well, we just have to sub in g of x wherever we see x here. So this will be 6 times g of x all over 3 g of x squared plus 2. And g of x is x plus 5, so this is 6x plus 5 all over 3 times x plus 5 squared plus 2. And then we have to multiply this out. We get 6x plus 30 all over 3x squared plus 10x plus 25 plus 2. And you could finish simplifying this, but we don't need to, because all we need to do is evaluate the derivative. That's the main thing we're looking for. Okay, so now we have to sub in x equals a quarter into this. So we get 6 times 1/4 plus 30 all over 3 times 1/4 squared plus 10 times 1/4 plus 25 plus 2. And this equals 0.372 to 3 decimal places, which is what they asked for. So the derivative of f of g of x evaluated at x equals a quarter is 0.372. And now it's a bit of a long-winded one, but none of these individual steps are that difficult. It just looks kind of ugly.